Welcome to our Checkpoint 4 presentation of the remedy models. So here we have some outlier plots regarding the studentized deleted residuals showing some points outside of the thresholds, along with our hat values showing the leverage, which there appear to be some high leverage points and some that reside along the line. Along with that, looking at our Cook's distance model, we see that there is one point that looks significantly higher than the others, while also some more riding along the line, and the DFF-ITS model that shows a fair number of points outside the threshold lines, indicating some potentially influential points. Along with that, the DF-beta plots for each predictor in our model being the intercept, which is total crimes, percent population under poverty, percent not high school grad, percent unemployed, and police budget per pop. For the majority of the plots, there appear to be points that are just right outside the thresholds, indicating some potential outliers, but for the police budget per pop, we see another point that is much greater than the other points in significance. So looking at our influence plot, we notice that there are points sized by their Cook's distance, and looking at the Bonferroni thresholds, near the beginning, there are points that exceed this Bonferroni threshold from the upper and lower thresholds, and there do appear to be that same point from earlier at 292, which is very high leverage, and it's much larger than these other points due to having a higher Cook's distance value. So to downweight the effects of these outliers, we performed a robust regression remedy. So this is our OLS model, which shows estimators of 4,838 total crimes, which with 350% population under poverty, 4.78% not high school grad, and then 135% unemployed and 0.001 for police budget per pop as the beta predictors. We performed the Tukey and the Huber model, which for the Tukey model, it sets high outliers to a value of 0, negating the effect of the outlier, whereas the Huber model does downweight the value of the outliers but still gives it a non-zero value. So from the Huber and Tukey model, both values demonstrated lower standard errors, indicating an improvement in the variance of the model. And while this model does show that all the predictors fell within the range of the 2.5 to 97.5, 95% confidence interval, the model that we found better fit for this was the Tukey model, as there was a large number of outliers which could indicate that their influence would be better negated to 0 rather than keeping the influence with a Huber model.
So while previously shown none of our VIF values were above 5, we still wanted to do a ridge regression to account for any multicollinearity amidst the predictors. So as you can see here, we did find one significant thing that matches one of the other remedial methods later, is that percent not high school grad has no effect, is not statistically significant. And we want to note that while there is a statistically significant effect of police budget per pop with those bootstrap confidence intervals, the confidence intervals just go from 0.0000027 to 0.0042033. So while it is significant and doesn't cross 0, it is a very, very, very small effect. And as you can see in the trace plot below, the ideal lambda was 196.76, which with the standardized coefficients has a very high percent population under poverty, while everything else remains quite low. So with that ridge regression, showing the cross-validated MSEs, the OLS actually had a smaller CVMSE, which means likely predictors were not highly multicollinear. And ridge adds a bit of bias without enough variance reduction to improve predictive accuracy, which just sort of shows that we don't need to do a ridge regression. It also shrinks all coefficients towards 0 and reduces the variability of coefficients across those bootstrap samples. And as you can see in the graph here, all of these error bars are overlapping, and so there is not a significant reduction in that variability.
Then we also want to do weighted least squares limiting. So as you can see this plot, as our fitted values increase, our residuals increase, indicating that we most likely have heteroscedasticity. Next slide. This is just showing the magnitude of our residuals with the value of our variables. And then for every variable, as they increase, the absolute value of the residuals increase. Next slide. This is our Booch-Pagan test for our original model, getting a very low p-value, so we would have heteroscedasticity. And then our p-value is 1 when we do one iteration of weighted least squares. Next slide. So this is our model summaries. See our value for police budget per population is very small in both models, but the values are pretty similar between them. And then also, can you go back? Percent not high school grad has a little bit more significance on the weighted model. And then you can go to the next one. So these are our 95% confidence intervals for OLS and WLS with T based and bootstrapped. You can see they're mostly the same for all of them. There's a little bit of difference for percent unemployed, and the values for police budget per population were very small, so I multiplied them by 10,000. So they have what seem like they have a little bit of difference, but it's not that significant because they're such small values unmagnified. Okay, next one. The summary of our weighted least squared is we have heteroscedasticity with our OLS model. With one weighted iteration, we got a constant variance with p-value of 1. So with any confidence level, we won't have heteroscedasticity. Or between models, our squared increased by 0.0601 from 0.4295 to 0.4896. Most of the confidence intervals confirm the reliability of the weighted model, as the t-based intervals are close to the bootstrap values, with percent unemployed being the exception when they start to diverge, and police budget being very small values. So it seems like there was one, but they're very small without magnifying them, and they also include 0.
Another assumption error that we had before was the assumption of normality of errors. We were failing that assumption, so in order to fix this, we did bootstrapping on the original model. And we can see that the bootstrapped model has a larger confidence interval for basically all of the predictors, but a very important notice that we have is that the percent not high school grad was originally ruled as significant, but now it is ruled as insignificant because it includes 0 in the confidence interval. That coincides with the discovery that we made during ridge regression, showing that perhaps we should not be trusting the percent not high school grad. So looking at model improvement, we have the different models using different numbers of predictors here, and we can see that the R-squared adjusted is relatively similar with all of them, with it being lower with the 1 predictor and highest with 4 predictors, but with 3 predictors it's very, very close, and with 2 predictors it's just slightly lower. We can also see that the Mallows CP is highest with the 1 predictor, and the BIC and AIC are relatively, the AIC are basically all the same except for the 1 predictor, which is the highest, and the BIC is fairly similar among all of them, with the 4 predictor being the highest and the 2 predictor being the lowest BIC, which is what we're aiming for. We also have this model which gives us many different axes. We have the Mallows CP on the x-axis, adjusted R-squared on the y-axis, and then point size is the press value, and color is the AIC value. So we can see that everything as supported there is relatively close together, with the 1 predictor model having a much higher Mallows CP than everything else. So with model improvement, looking at all of our accommodations for every single model, we can see that our best 1 predictor model would be with the population under poverty. But when we add the 2nd predictor, it is best that we add the not high school grad. And our third predictor, if we wanted to have one, would be the percent unemployed. But the difference between 2 predictors and 3 predictors is very little, while the difference between 1 predictor and 2 predictor is quite a bit for the CVMSE value. So the 3 predictor would be best. And to conclude, we found that in total, percent unemployed, police budget per population, and percent not high school grad are all insignificant in the original model, and the latter is important because we previously believed that it was significant. However, the best model in terms of accuracy and other factors is the 2 predictor model, including percent population under poverty and percent not high school grad. And after bootstrapping the new model, we can see that each predictor is now significant. So this one that was kind of going back and forth between significance is now significant after bootstrapping, showing that it is a good predictor. And that's all. Thank you.